Hey guys, welcome back. Let's talk about installing Knee. I didn't cover any of the setup in the last video, and as a result, it's going to be hard to replicate the workflow you saw. In this video, I'm going to go over all the background and cover pretty much everything from the last video in some amount of detail. Sorry in advance, I think this is going to be a long video because of that, but I want to be fairly thorough about the explanations and stuff. Just to cover everything. So first off, here's the Knee website. It's just the repo. And there's a few things that you might be interested in here. There's some documentation I wrote. It's not the best. It says really smashing. It's not. Knee by example is probably a better place to start than Knee cheat sheet. Michael Bilo wrote these, and he had the advantage of not knowing Knee to begin with. He learned it after I had written it. So his docs are going to take that into account. They're going to be a lot more, they'll be a lot nicer to read through because he knows what is confusing if you don't know it already. And then the web UI examples might be worth checking out if you're curious. So the first thing to do, let's get this installed. I've got a Linux system here, and so if you were just to install this on a brand new Linux system like Ubuntu, you could also do this on Mac OS. Then you're just going to clone the repo. I've already cloned it, so it's complaining. But if you clone it, you'll have the repo available, and then you symlink the Knee script into your bin. So if I were to do this here, you need the PWD because symlinks are relative to where they end up. And I've got it installed already, so it complains again. But those two commands will get Knee installed for you on your system. Once you have Knee installed, you can open up a web user interface. And the way you do that is you just run knee-js. That gives you a web address. It takes a minute, but right now it's computing the data. You can see that in the terminal here where you ran knee-js. And this is something I'll get into, the monitor display, but it's really useful for batch workflows. So here we go. It's loaded up in the browser, and you can explore this. I'm mouse wheeling to zoom in and out. If you drag, you are panning in 3D space, and then shift drag is rotating. There's another mode, and it's a little confusing if you don't know what's going on. So if you hover over here, this is your camera settings. And this includes your translation matrix here. So you can see this. Oops. If you click this and the orange bar appears, that'll cause it to stay fixed. It'll pin it, so it won't go away. So if we drag this around right now, you'll see the translation changing. And then if you rotate this, you see the rotation down here changing. And these orange things here highlight what you're going to modify if you just use your mouse. And they're keystroke responsive, so when I hit shift, it changes to highlight R for rotation. Scaling by default is not bound to anything in camera mode. If you hit tab, you go to object mode. And in object mode, you scale individual axes. So in camera mode here, we were changing the distance away from the center point, the origin. But that's kind of a general zoom. Maybe we want to inspect an individual axis. So to do that, we tab over into object mode and then use the mouse wheel up and down. And we can scale it one axis at a time. And by default, it's going to snap to axes when you do these things. Also, if you drag this around, it's going to snap it to the object axes as well. So you'll notice we're only translating along one axis. The others are remaining frozen. And it's snapping to the nearest axis that matches the motion that we're making. There's a couple more things here in this panel, brightness, which you can scroll up and down. And that just influences the shading that is used to display things. And this is saturation. If you scroll this up, the pixels will turn white with less overall brightness. If you scroll it down, they'll take longer before they drown out to white. And it depends on what you're looking for. If you're looking for brightness concentration, maybe you want to scroll that up. If you're looking for color, you want to keep it fairly low. I think 0.03 is the default. All these boxes will accept numbers and expressions and so forth, so you can do that. And most of them support some kind of scrolling. So I'm mouse wheeling and it scrolls it along a log scale. Just kind of useful to know about. So that's the camera settings. Oh, I didn't cover this. and I'm going to defer on that. This is going to change in the future anyway. It's lame the way it is, and it's complicated and not really worth explaining. All right, this is the data preview. Another pop-out panel, and what's going on here is this is just the columns of data. I'll get into this in a little bit more detail when I cover the specifics of using our data sets. Speaking of which, let's go ahead and download those. The first data set we used was, I think, the taxi data set from Chris Wong. If you Google that, or DuckDuckGo, Chris Wong NYC taxi. Yeah, here we go. You can find this on his website. Chris Wong, where is it? Oh, you probably have to include FOIL. Freedom of Information Law. Here we go. So this is the Borrow data. He's got two of these. I was not looking at the Borrow data last time. I was looking at Manhattan only. That is... Oh, great. They're on academic torrents. That's probably the right way to go. Yeah, I would do it here. And this is the FAIR data. There's another one called the TRIP data that is probably better. Oh, here we go. Chris Wong, open data. Yeah, this is the site you want, the page. I use the TRIP data. And this is a bunch of CSVs of stuff. I've got it downloaded here. We can take a look at it. And this is a great opportunity to talk about Knee in command line mode. So let's go ahead and do that. Knee is a command line tool. It is not fundamentally a visualization tool, although it'll do visualizations for you. So if you've got a setup like this and you've got some data downloaded, you want to take a look at it, you run Knee on that. So trip1.csv is one of the CSVs from the FOIL data. And if you run Knee on a file, it's going to just less it for you. So we're in bin less, or user bin less right now, and it's just showing the contents of the file verbatim. So the first thing we should do is let's transform this into tab delimited rather than comma delimited, and we do this with the FC operator. Capital F means split fields, and then C is a shorthand for commas. Another way we could do this is with a regex comma, but we're going to say FC here because that's the idiomatic way to do this. I'm going to hit dash capital S so that we're not line wrapping. We can see things more clearly. So now the line just kind of extends off the right hand of the screen and disappears. Okay, so we have a number of fields. They're not well lined up in this display. The headers don't line up well with the data. Knee doesn't really fix that for you, unfortunately. Let's build a text file of the pickup date time and the latitude and longitude. And the way we do that is we field select fields A. Let's count these out. So we got over here we have A, B, C, D, E, F, G, H. So we have AGH. So FC, F, A, G, H. Awesome. That's the data we're looking for. Lowercase f is field select, and it's also field remap. You can duplicate fields, for example, AAGH to duplicate the A field. But this this operator is what you would use to reorder or duplicate or drop or choose fields from a wide data set. So now we have the fields that we're looking for. This data looks about right. And let's drop the first row off because we don't need the column headers anymore. We do that with R-1. Negative numbers mean drop this many rows. So now we have this. Now one thing you'll notice is that this knee command is coming back very, very fast every single time. We run this and we get results in well under a second, probably about 100 milliseconds if that. And you know, and we can stream this. The file is not that small. It's 124 megabytes, and Knee couldn't process this that fast in its entirety. If we said to dev null, it would take a few seconds, right, or a second. So Knee is streaming the data into less. It's not processing the entire thing at all. And this is great. This arises because Ni has the same kind of pipeline workflow that Bash does. And actually, I'll talk about a fundamental equivalence here. You'll notice that we have a bunch of operators chained together, each one transforming the stream from previous. And this is exactly the same as this. This will behave exactly the same way. Keep that in mind when you're writing pipelines. Adding more operations to the end is cheap, and you almost never buffer the data. There are a few exceptions. If you sort things, Ni has some sorting operators. For example, if you say G for group, group will group all rows that are the same together, and that's going to take a bit because we're running Unix sort, and that's not a fast operator. But in general, Ni will stream when it can, and that's the thing to remember here. Okay, so now that we have the data in the format that we want, let's save this into another file. And we can do that by redirecting, or we can do it using Ni's redirection operator. I'm going to use this one here. And let's say trip1 processed. Great. You'll notice that the output from the Ni process is trip1 processed. And this redirection operator is almost the same as Bash's. If you say this, Bash will redirect for you. If you say this, this operator here is quoted in Bash terms, so it passes through on the command line to Ni. And Ni sees this and knows that you want to write it into a file. There are cases when it's important to be talking to Ni as opposed to Bash. For example, if I had sent some of this pipeline over an SSH connection, as in SR0 whatever, this would write a file on the remote system. And if I had tried to do this with Bash's redirection operator, it would have written a file on the local system and broken the grammar for Ni. So Ni does have to implement its own redirection, and it's worth being aware of that. All right, let's talk about how we access this data. We have this in a file on the server called trip1 processed, and the current directory is nyc from my home directory. So if we were to, I'll do this manually, if we were to SSH into R3, and then we said cat nyc trip1 processed, pipeless, we would see the data come in like that. So the data is accessible, and Ni can access it as well. So given that the data is remote, we're going to need to use the SSH operator, and the SSH operator moves a segment of pipeline over to a remote Ni instance. And when you do this, Ni will install itself on the remote machine, run the pipeline over there, and then stream the data back through the SSH connection. So if we have sr3./nyc trip1 processed, this will start pulling data down from the server, and we'll see it come up here in the preview window. And there it is. In the last video, I pulled out the hour component of the time using a regular expression. And the way I did that was I entered a Perl context, a Perl mapping context, and transformed each row using a Perl expression. And I'm going to do the same thing here. So let's go ahead and launch a Perl context with P. You'll notice in the explain output that it says Perl mapper and is waiting for some code. So if I put foo here, it's going to show up as foo, and that's the Perl code we're evaluating. I would really recommend at this point reading some of the documentation if you don't know Perl already. I'll show you where it is. I'm going to go to Bilo's documentation because his is better than mine. Here we go, Ni by example. I really recommend reading through Michael Bilo's documentation. He's done a brilliant job covering everything going on here in a lot more detail than I'm going to be able to cover in this video. And he does it from a really nice perspective, which is he's going to explain things from the ground up. I will miss things because I've known Perl for a long time, and I don't remember how confusing it was to learn it. You can read through the Perl documentation that I wrote, and this documents the details of the Perl mapping context. So it'll tell you all about the functions that are exported to you, how Perl mappers work, and the kind of the intricacies of it. But if you want just an overall picture of what's going on and what you need to know, Ni by example is really, really good. I highly recommend it. When you're writing a Perl mapper, you are specifying a function that will be called once per input row, and you get to specify what happens with that data. And often what you'll want to do is you'll want to call the R function, which emits an output row. So for example, if we wanted to output just the latitude and longitude, I guess longitude and latitude in that order, we could say B, C, and this would output just the longitude and latitude in that order. B and C are shorthands here for the fields, the fields and columns B and C in this row. So already we have the data in Cartesian coordinates in 2 dimensions, and we can go and pan around to locate it. So let's go ahead and translate over to the data center, and we do that the same way we did in the last video. We'll translate by positive 74 and then negative 40.7. Now we can zoom in. Yeah, and we see a lot of taxi pickups. Actually, a lot more than we did in the last video. This data set is much more comprehensive. I'll probably have to download all of it because this is great. Wow, look at that. Yeah, this is great. So, right, where was I? Okay, let's go back to the original data set here. So we don't just want the 2 column values. We actually want a value from here. There are a couple of ways we can work this out. One thing we can do is we can immediately write a regex right here. So we can say space, 2 digits, and a colon. And that's a unique match. So what we're going to end up with is the hour in the z coordinate. If we do that, yeah, there we go. We have 0, 0, and then eventually we'll have 0, 1, and so forth. All right, that's cool. So we have everything mapped out properly, and we see this giant stack of copies of New York City. In the last video, we did the axes just a little bit differently. Rather than doing longitude, latitude, hour, we did longitude, hour, latitude. This is a quirk of the Knee.js plot interface, and arguably it could be better. So now we have these things stacked up vertically. The Knee.js plot interface, you'll notice that it has a turntable style of navigation. So if I rotate around like this, I'll zoom in first. So if I rotate around like this, it's always within that plane, even if I'm down here or up here or so forth. And you'll notice that this is very easy to control. Knee will rotate around the y-axis preferentially. And I considered it a feature when I wrote it. I think it probably still is, but it makes some things difficult if, for example, one of your fastening axes is on the z-axis. Realistically, when you're doing stuff like this, you're going to want to assign y to be a layer rather than a continuous coordinate. You want y to be discrete if that's an option you have. Okay, so this is basically where we were in the last video. We've now got the taxicab pickups. They're on 24 planes. We got the y-axis as the plane axis, and we can zoom in and out with the mouse wheel like that in object mode. So now let's talk a little bit about the OpenStreetMap data. It's a bit more complicated and it's a much bigger data set, so let's go ahead and get into this. When you download OpenStreetMaps, you're going to go to planet.openstreetmap.org. And you can get the latest weekly Planet XML file. That's the one you want. It's giant and it's bzipped, and there's a couple of problems with both of those things. I'll go ahead and show you a copy of this data here. The first thing you want to do is transcode the bzip into something that is faster to decompress. Bzip is one of the slowest compression algorithms there is on the decompression side. If you have a bzipped file, you can realistically expect between like 20 and 30 megabytes per second of decompression. All right, let's talk a bit about the contents of osmplanet.lz4. This is exactly the same file as the bzip2 I got. I just transcoded it already. Okay, so OSMPlanet contains a bunch of different types of tags. We have change sets, tags, nodes, and ways. And in this case, let's simplify things and go straight for the nodes. We can use Knee's row select operator with a regular expression to pull out the rows we're interested in. If we do this, this is analogous to grepping for node. The difference here is that it's using Perl to compile the regular expression as opposed to grep. In certain cases, this can actually make a big speed difference, although I think in most cases it doesn't really help you that much. And in this case, it'll be the same either way. So let's run that. Okay, notice while this is running, we have some stuff going on the terminal. This is called the knee monitor. If knee detects that your thing is running for longer than a couple of seconds, it will start showing you intermediate results. So what we're seeing here is the output from the file cat, and these are actual output lines as they're occurring. There's a few things up here that are happening as well. So here we have the total amount of data that's been output from this operator, and then here we have the data rate, the data throughput. Let's talk about this third field. This is the data pressure indicator, and it's one of the best things about knee, I think. It's very useful for figuring out where your bottlenecks are. Positive data pressure means that the process consuming data is running more slowly than the process producing it. Negative data pressure means you have a vacuum, so the process downstream is willing to consume data faster than you're producing it. In this particular case, the consuming process is running almost 4 times slower than the producing process, which is cat multi. What that means for us is that the row selection operator is the bottleneck, because this should be negative coming from a file. Okay, so R is a bottleneck here because the data pressure is positive, meaning that R is creating a backlog of data, and then LZ4 is slowing down as a result. What we want to do is alleviate that bottleneck by horizontally scaling out the row matcher. Luckily, we can do this because knee provides a capital S operator for horizontal scaling. So it works like the SSH operator, but in this case, the brackets are the section of pipeline we want to replicate. And what we're saying here is, let's launch 4 of these processes and then distribute the data across them. Then when we run this, watch what happens with the throughput numbers and the data pressure. All of a sudden, the throughput jumps to 400 megabytes a second, and the data pressure is now negative. The downstream process is willing to consume more data than we can produce. In fact, its delays, its read side delays, are 1/4 of the delays of the writing process. The reason I know it's 1/4 is because these are tenths of powers of 2, so it's 2 to the 2.4 is the ratio, and because it's negative, we know that the downstream process is faster than the upstream process. Anyway, we're streaming the data. We'll now much more quickly find the list of nodes, and there they are. Okay, so we have nodes, and it took a while to get there because we had to seek through all the stuff that wasn't nodes. Now, we're going to iterate on this pipeline a few times because we're parsing out the latitudes and longitudes from every node. So if we make a mistake, we're going to have to pay that fixed cost every single time. Rather than doing that, what I'd like to do instead is stream the nodes out to a file in advance so that we can iterate more quickly. Now, if this were a traditional workflow, we would probably say something like gzip nodes.gz. In knee, a more idiomatic way is to say this. And in this particular case, I'm going to use LZ4 because the decompression speed is about 4 times higher than gzip. All right, that's running. I'm going to get some more Chardonnay and report back when this is done. 33 gigabytes and counting. I think this is a good place to actually cut this video, and I'll upload the next one shortly. I would recommend reading through some of the stuff in the knee doc directory. In particular, the knee by example is absolutely great. Michael Bilo wrote all of this, and it's phenomenally well done. I mean, it's fun to read, explains things really well. This is the documentation I wish I had written, but I was too lazy, and I'll never write docs this good. So truly, I mean, read through this. It's absolutely fantastic. You can follow the knee tutorial here, which is my original. It's not as good, but it does cover knee kind of by concept, and I think it might appeal to some people, depending on how you like to learn about things. So everything up to Perl, and then the rest of it is kind of mediocre, honestly. But there might be something good there. So yeah, I'll catch you guys next time, and we'll cover the rest of the pipeline, including the regex to extract the latitudes and longitudes from these nodes, and then how we combine the data sources together to get a single unified visualization. So I'll see you guys next time.